Well, specifically in aviation biofuel, I mean, it's the most promising application actually for the biofuel area of microalgae, because aviation fuel is regularly super expensive. I mean, the one most expensive for the operation of the airlines, and I mean, they need it. It's crazy the amount of fuel that the aviation industry consumes. I mean, it's a lot, and they need it like always. I mean, they cannot stop, because if not, they don't fly. And that way is super important. And they are looking into ways to getting a source of fuel that can help them. It doesn't matter if and let me tell you that I have heard that it doesn't matter even if it is expensive, a little bit more expensive or the same price, they will buy it because they need it. They need it. That problem is in getting it like from petroleum sources or normal sources is getting expensive by the minute. And with algae, that biofuel is gonna be more in equilibrium. It's gonna hit a price, but it's gonna
be more equilibrium.
And it's really good. I mean, that it has been tested before. The fuel for aviation industry from algae, the biofuel from aviation industry from algae. So it has been tested. It's good. It works really good. The engines take it really good. I think there are different like small modifications or non-modifications. I mean, small variances that you have with normal fuel. But I mean, in the whole step is really good. I mean, it's a good substitute of normal fuel. You can use it and you won't have problems like it's just like using normal fuel, but it's not that the optimum level. How can I say it? It's not the same as normal fuel, but it works the same way. That's like
so it's maybe not as efficient, but like efficient,
yeah.
Way, yeah, not quite the same efficiency, yeah.
Yeah, we have. There's a discussion also in that the efficiency test point of view. I'm saying it works the same way. I'm not like it works the same way, because if we get into that, it gets a lot. We get into a lot of details that are really specific that doesn't have, but it works good. But the problem there with the algae growing to be biofuel for the aviation industry is the volume and the scale that you need in order to have a good proportion of biofuel to be able to sustain an airport operation as a normal provider, right? O sea, it takes a lot of steps. One thing is you get the algae oil, the algae biofuel, the algae oil, then the algae biofuel, and then you put it in a plane and it can fly. That's one thing, right? You can get enough quantity to fill a plane, maybe. With a big production process going on right now, big, because you need a lot of oil, of algae to do this. So when you have that, then you have to figure out, okay, it works, but now I need to fill a tank daily of 1 million gallons, just to say something, right? How I'm gonna do that, right? I need a scale of 100x and 3,000 acres and all this and this amount of energy and all of that. And even then, for the aviation industry in Kentucky, I believe they have Kentucky in the United States, they have something going on regarding that, specifically for the aviation industry, something that they are really big working on a lot of years, like 10 years, just to get to that industry. And they continue to work, but they estimate that maybe in 10 years, they will be at a scale where they can start implementing some fuel to the planes, because it's not like, okay, I'm going to buy from you right now, but if you don't have, I'm going to steal you. No, you need to be able to continue to provide the biofuel, and that makes it a lot harder. In order to transform it, you need a lot of energy. You need a lot of stuff, temperature and stuff that you need. And in order to get that fuel and then get it that way that you're going to put it into the tank, so you need to clean and do a lot of processes. All that is a big process. I mean, by itself is something super huge, because the aviation industry is massive. So that's a good point that you mentioned there, that the biofuel from the aviation industry is the most promising source of biofuel that we have with microalgae right now, researching through the world, because biodiesel already has gone out in a lot of big company names. They already said like, okay, we try everything right now. It's simpler for us to continue extracting oil from the ground instead of building algae to transform oil. So
well, this is it, isn't it? It's the associated costs, and the other environmental impacts. Like, there's a lot of cereal crops, like we have oilseed rape here in the UK, and that's used for biofuel sometimes. So, which is great, but actually then you're taking like productive food land, agricultural land out of use, and then that's just shifting food production to somewhere else, which is not perhaps managing it in the best way. So you're not really like solving the problem. And also, again, the sheer amount of land that you need is crazy. I mean, this is the problem with fossil fuels, right? They're too good. They're too efficient. Like that's the challenge. And then with the algae as well, I remember from looking at this before that one of the big challenges, as you said, is just the amount of land and space you need to actually create the volume just makes it basically unaffordable, essentially, because the scale required is so vast. So it kind of, in my mind, I kind of see it like two ways. There's like, you either go like really industrial on this like big scale, but it's really expensive to do and quite challenging. But then also, doing something like what you're doing, where actually you're utilizing it in lots and lots of, you sort of have lots and lots of small little plants and interventions all over the place. And like cumulatively, actually, you end up creating a significant volume, which can then be utilized, but it's just not centralized. So it's how, it's the sort of two different approaches, basically. And it's like, it's not necessarily that one is better than the other. It's just each has got their own set of challenges, right? And it's difficult to figure out like what's the best. And actually, we should probably try everything at this point.